Take the derivative, determine the derivative of the following function. Y is equal to sine of x over x. Well, these are two different functions. This is a trigonometry function, and this is a power function. So we have one function here, and we have the other function here. So really this is y is equal to f divided by g, and we want to take the derivative of that, the d by dx of that. And we have that. We have that as a rule right here. It says, ooh, new formula sheet, that's nice. Quotient rule. If you have a derivative of a function divided by another function, is equal to the derivative of the first function times the second function, or the bottom function, minus the derivative of the first function times the derivative of the bottom function, all divided by the bottom function squared. Okay, here we go. dy by dx, and we're going to take d by dx of this thing. We know what that is. It's going to be d by dx of f of g. We already know what it is. It's going to be, well, I can write it, I can copy this down, I guess. It's going to be d, but instead of putting f, I'll put what f is. F is sine. So sine of x times g, which is going to be x, minus f, which was sine of x, times dg by dx, dx by dx. Okay. All over the bottom squared. Okay, here we go. So derivative of sine, I actually have that one. There it is. Derivative of sine is cosine. So this is going to be cosine of x times x minus sine of x times derivative of, okay, that's the polynomial, the power function. It's to the power of 1, and the a coefficient is 1. So 1 times 1 is 1, and 1 minus 1 here upstairs will be 0, and x to the power of 0 is going to be 1. So this is just going to be 1. All over x squared. So we can clean this up a little bit. The derivative is equal to x cosine of x minus sine of x, all over x squared, all given by the quotient rule. I want to show you that you can give the same thing from the product rule. I've been claiming all this since. I just never used the quotient rule. I use the product rule because you can always bring the downstairs upstairs just by giving it to the negative power. So just to show you, this is the same function right here, x to the negative 1. That's the same thing. They're the equivalent, right? X is to the power of 1. If you bring it upstairs, it becomes negative. So there it is, x to the power of negative 1. Okay, and now we can use product rule. So if we take the derivative here, d by dx, so it'll be dy by dx, and this is going to be, remember the product rule here, is going to be df by dx times g, where here is going to be my f, and here is my g. Okay, so df by dx is, well, we know that one is cosine of x, times g, which is going to be x to the negative 1, plus f, which is sine of x, times derivative of this one. So this is going to be negative 1. Negative 1 comes down, so minus 1 times x to the negative 2, right? Because negative 1 minus 1 is going to be 2, and we're using the power rule here. Okay, so let's clean this up a little bit. So we're going to get cosine of x all over x to the power of 1. That's this one. Plus, oh, it's actually minus, so I'll put the minus up here for now, and I'll switch it next time. Sine of x all over x to the 2. Okay, x squared. Now, if I wanted to make these over the same denominator to bring them all together, I'll just multiply this equation by 1, which is x over x. That's multiplying the equation by 1. So then I'm going to be left with x cosine of x over x squared minus sine of x over x squared, meaning we can bring them together. And lo and behold, we get the same thing. Both done by quotient rule and product rule.